It's time for some quiz. Let's try to understand what is our understanding. We'll start with the first question. So, what is a distributed system? What do you think? Is it one machine processing a file, or it's a multiple machine processing a file, a traditional system, in-memory computation? What do you think? What is a distributed system? So, distributed system, as all of you said, is like it's multiple machine processing a file. Okay, very good. Let's go to the next one. What is Hadoop? What do you think? Just go through option. Is it an in-memory tool, or it's a computing framework, or it's a framework which allows distributed processing, or it's a search and analytical tool? What do you think is the right answer? Right answer, which is it's a framework which allows for the distributed processing of large data set, cluster, counting, compute, and all. So one thing which is very important to understand is Hadoop is not a tool. Most of the people think it is a tool, and maximum people have understanding that it's kind of a database. So even in the projects also, sometimes people feel it's kind of a big database. Okay, Hadoop is not a database or it's not a tool. It is a complete framework which is designed to do distributed processing of the data. It's not only storing the data, it is definitely storing, but it allows us to compute the data in a distributed fashion. That's very, very important to understand. Okay, it's not a database, it is not a tool, it is not some in-memory analytical or search engine tool. It's not all that. It's a framework that allows for distributed processing of a large data set. Okay, the way it works is divides the data into multiple nodes known as commodity hardware, and then it runs all the program, whatever our program it runs all of them in parallel. Okay, very good. So, all right, which of the following is not a key characteristics of the Hadoop? A, economical, B, adaptable, flexible, reliable. Okay, all right, good. So, yeah, so the answer is B. Most of the things we have learned, like it is
So, but why it is not adaptable?
see, adaptable means it automatically adapts to some behavior, right? So Hadoop is not adaptable. It is not adapting. It is economical, it is flexible, it's reliable. The fourth one is not fitting in because it's not that. What is adaptable? Like if you make some changes, it will adapt to whatever changes you are doing. Hadoop is not that, right? You have to design the thing the way it is designed. So you have to follow its own principles. Okay. Okay. Which of the following is used in data storage processing stage? Okay, well, we just discussed all the components. So can you tell me like which one is used in the processing stage? Data storage. Okay. Raghav, I got it from Raghav. Sekhar, Samba, Vahid, Pranal, Mansi. Okay.
Dheeraj, what if we are going to have one more option as a scope or what is the other one?
Scoop and flow.
Loom. Yeah.
So
Then what?
those are also not the storage.
But
Scoop.
it is not talking about the storage. It is about the processing stage. So they
No,
are
no.
participating in storing a data, though they are not storing any data.
Yeah, you're right. So they are not storing a data. They are just an ingestion tool which are helping us to move the data. They are helping in the data movement, not in the data storage. So it is talking about data storage.
Processing.
Data storage processing, yeah.
Yeah.
Okay.
Then what should be the right answer in that way? If it is data storage, processing, and if we are going to have scoop and flume as well, then all these three will be the right answer, or only the HDFS will be the right answer?
See, data storage, only STFS and HBS will be doing the data storage. And the moment why HBS we are saying, because HBS can do some sort of processing and all, right? But they are helping, mostly they are kind of a data storage. The intent of this question is which component is used to store the data? That's what this question is.
Dheeraj,
Yeah, actually the processing. Sorry, please go ahead.
yeah, I mean, why HBase is explicitly highlighted? Because HBase is even in underlying storage is HDFS, right?
Yes, but it's like Oracle, right? So sometimes people think, okay, Oracle is a storage, right? So no matter what underlying you are using, but it's
No, but
storing the data.
Oracle will classified as a database, not as a storage. But
Yeah,
storage, if it comes any other mount system, either file system or probably it like any other network storage system, in NAS
that's right.
or SAN, or something like.
Right.
So I'm just like because it's kind of confusing. Like, see, when it comes to HBase, yeah, HBase people call as a data warehouse kind of application, what a database. But here explicitly you are asking as storage, so that's why I just anyway.
Yeah.
Thanks.
Yeah, so yeah, terminology could be here and there, but data storage, like you should sometimes because okay, I'm storing my data in HBase, right? Although underlying file system is I mean, in that case, every file system is the one which finally stores the data, right? So any storage will always happen on a file system. But why is it like, because HDFS is also kind of a file system which is running over the Linux file system, right? And Linux file system is the actual storage for both of these. So if you go on a low level, then finally it will end up with some operating system file system storage, right? But the reason why we have to choose HDFS and HBase is because these are kind of an abstract layer which helps us to store the data. Either you store it on HDFS or you store it on HBase.
Okay.
Okay. So that's the reason. Okay. Now here comes your favorite question. What is scoop used for? What is scoop?
Yes.
Yeah, there is one question here. See, generally, scoop is, of course, used to read the data from a database and write it to the Hadoop, or the vice versa. But even we can use the file to read the data and write it to the database. So why we are specifically restricting that? Oh, it is only for database.
How you use a file?
No, that's what actually we I mean the initial.
So I didn't get it. So you are saying we can use file. So you are saying you will export the data from your database. You export it in a file and then you transfer it. Is it what you are saying?
Yeah, generally that's the see basically in one of the project actually we want to archive our database data into low cost system. So what we did a scooping and out and putting into some CSV files. So that kind of model actually we have just done it. So I'm just
so you are doing Oracle or any database export using those utility and putting it in some file and then offloading it, right?
Yes, that's correct.
Yeah, that's true. So definitely that you can do. You can export it using some Oracle utility and you can transfer it. But assume if your database is some 200, 300 or 500 gigs, that's fine. You can use those export utility, transfer it to a file. But let's say you have a database where you have 1500 tables and span across maybe let's say 10 terabytes of the data, right? And you need the data every day. Okay. So what you will do? Will you choose file utility to transfer one by one and run so many SFTP jobs? How about the network bandwidth? How about the performance, right? So those things will not scale out.
Okay. Because actually generally the reason why we opted that time is basically customers not ready to expose direct connectivity to the database. They said like, no, we will give you offline data, you just pick it up. So that is the model. That's
Yeah. So sometimes you get this type of issues like the security challenges and all. There are some ways to handle those also, but you are right. If you are exposing a scoop, then you have to give a direct connectivity from the Hadoop layer. And if your database is so restrictive, no people don't want to open up the ports, you end up in dealing with all this type of issues where you have to export it, and yeah, so that definitely you can do. But the reason why Scoop gives us an advantage is Scoop will run multiple mappers, right? So assume you have to offload a 500 GB of a table, for example, right? So 5 GB, if you are using some utilities to dump it as a file and then transfer this 500 GB, will be more tedious compared to if you run a multiple parallel scoop jobs, which will directly connect to a database and then parallelly it will pull the data. Right? So scoop performance will be better compared to the first choice where you have to manually do all of that. Because over here you are running it parallelly. You are not pulling the data in one thread, you are pulling the data in multiple threads.
okay. So, I mean, I'm sorry to extend that. So when you say multiple thread, that means it will be a multiple connection to the DB, or it will be a one connection where internally it will divide and pull the data.
Multiple connection, so we have to restrict it to, let's say, 8, 10, depending upon how much database can open.
Okay, fine. Yeah, please. Thanks.
Okay, all right.
So here actually one understanding. I mean, then what does it mean? Scoop can read from file and can write to file also.
Scoop can read to file. Scoop can read from a database, relational database, and can write to a database.
No, database is fine. Anyway, we have learned that. But my question now is like the way we were discussing. So does it mean, I mean, that Scoop also allows to read from file?
No. Scoop only is to read from a database and then push it back to the database. The other conversation that we are having was to use some export utility like Oracle export utility to export it to a file and then transfer the file to Hadoop and then do all that. So Scoop don't do all of that. Scoop only connects from the database and pushes back to the database.
No,
So,
the conversation that we were having, in that actually we were using Scoop, right? I mean, the way we were discussing.
No. The conversation that we were having, he was saying we will not use the Scoop, but we will use other utilities like Oracle export tools or any other tools to export the file, to export the database data into a file using some Oracle tools or any other database tool and then transfer them. What he was saying is, since they did not open up the database connectivity due to some security issues, so they went through this route. So they manually used some other tools to do that. Scoop will not do all of that.
Yeah, okay, fine. So yeah, then it's fine. So I was thinking like they still used Scoop, so they did not Scoop. They did not use Scoop. So because of the security issues, they went to a different route and they avoided Scoop there.
Yeah.
Right.
Yeah.
Okay, thank you.
Okay. So let's quickly go on to the next question that you have. That concludes our quiz. Now, these are our key takeaway from this session. If you really think, what did we? If you just recall next 2-3 hours, so we learned that Hadoop is a framework for a distributed storage and processing. These two words are very important. Hadoop is doing both storage and processing. Okay, and that also in a distributed way. Second thing that we learned is the core component is HDFS for storage. Yarn is used for cluster management. We'll go in a lot of detail about this. MapReduce and Spark are the main components for the data processing. Okay. Now, what are the components that we learned? We learned about the Flume and the Scoop. These two are used to ingest the data. HDFS is used to store the data. Spark and MapReduce to process it. And then we have the tools like Pig, Hive, and Impala, which are used to analyze the data. Hue and Search help to explore the data, and then Uji is used to create some workflows where we can decide, I want to run this job in a sequence every day at morning 8 o'clock, for example, right? So those things we can do using Scoop.
Dheeraj, I have one question. Can you please share any pictorial representation which shows that out of all these applications or tools, for each node, whether we need to install all of them or only set of applications or tools will be required, kind of thing? Means from the scratch, let's say if we are going to have a database or data in one of the system, how we are going to distribute it among different nodes, what kind of things will be performed now, by each nodes, and is there anything which we are going to bifurcate from the workflow perspective? That let's say one of few nodes will work particular on this set of actions, and other nodes will work on these particular things, kind of thing.
Yeah, definitely. So the way it works is you have a lot of nodes in your cluster, but it's not necessary that all of them will do the same work, right? So for example, you have installed a Scoop in 3 nodes, for example, right? On 3 of the 100, I have 100, but I'm using Scoop on 3 of them. I've installed Scoop on 3 of them, and I'm running, let's say, 10 Scoop jobs on each of them. So total 30 Scoop jobs I was running.
Can you please open a notepad and just write it down, so it will be quite easier to understand?
Yeah, sure. Okay. So what we are discussing is, let's say I have 100 nodes. Okay. Now it's up to me how I want to distribute the workload. So let's say 10 nodes, I gave it to HBase. Okay. Out of that, I have 50 nodes, I gave it for the Spark. 10 nodes, I gave it for, let's say, Scoop.
So does it the specific node which is distributing all this thing, is it having a specific name or any specific like administrator node or something? Are we calling it?
Yeah. So what happens while you install the software, there will be some administration tools. So if you're using Cloudera, there is something known as Cloudera Manager. If you're using Hortonworks, there is something known as Ambari. Okay. So these are the administrative components which are distributing which software you want to install. You have all the options. You can just choose on which nodes you want to install what are the things and all. Right? So you can choose and you can distribute your workload like this. And there are some tools which will be present on all of them. Like 100 nodes will have the capability to run the MapReduce. All 100 will have the capability to run Hive. All of them will have the ability to run Pig. So these are capabilities which will be spanned across all the nodes.
Okay. So yes, that is pretty much clear. Now from tools perspective, we are clear. Then how basically we are going to distribute the data as well, or the whole data will be there at each node?
Yeah, so data will always be in your HDFS like this.
Okay.
It's kind of a shared file system. You put all your data into HDFS and it will distribute the data.
Okay.
So for example, I have a file one which is 100 terabyte, for example.
Okay.
Now, if I push this 100 terabyte, all of whatever conversion we are having, it will make more sense in the next few slides. But the way it's going to do is this 100 terabyte. The moment I push it into the HDFS, it will distribute this 100 terabyte among, let's say, distributed across 20 nodes. So how much it will get? Like each node will get how much? 5 terabyte each.
5 TB, yeah.
So 5 TB on each node. something like this. So all the distribution will be taken care by HDFS itself.
And so HDFS itself will be able to, means from there only we'll get to know that which particular data is with which node right now.
You don't have to worry about it. HDFS will know which data is where and how to deal with it and everything. You will not know which data is present on which node. You will know like on which nodes my file is broken down and it is present, but see, this is 100 terabyte of data. You never know my 10th record is present on which node. You will know these are 20 nodes which contain my data, but this particular record is present on which node. You don't have to worry about it.
Okay, okay.
It is present somewhere in the file system.
Okay, okay.
So mainly what I know is like file 1 is the file and which is there on HDFS. That's it.
That's it. Yeah, you don't have to think about anything. Once your file 1 is in HDFS, that's it. And the underlying storage and all will be all taken care by the HDFS. If you are processing a file 1, you just point the location of your file 1. So let's say you stored your file 1 something like this /data, your project 1, and then file 1. You just give this path, and then that's all is required. You don't have to worry about anything else. Underlying will be distributing.
So is it logically distributing the data, or the main file or the chunk of data will be sent to that particular node? Means I'm just out of my curiosity I'm asking.
I know you are very curious, and all of these components we are going to discuss in very detail, but just for your curiosity, is going to physically distribute the physical chunks.